Hi, so there have been some, let's say, misunderstandings with some of the binomial probability problems. And it's not all necessarily the same problem, which is why I'm not grouping them together, but it popped up in the eye color problem, it popped up with management, it popped up with another one, and it's fundamentally the same kind of issue. So I'm going to record this video and I'm going to try to put a certain type of misconception to rest. So let's start with like a really straightforward binomial probability. Let's say I flip four, let's say fair coins, and I'm going to let my random variable x be the number of heads. Great, right? And as far as binomial probabilities go, there's really not like a more straightforward uh, choice, really, for a binomial probability, right? I mean, so parenthetically, we should note that this means that n is 4, right? And that p is 0.5. Now, 0.5 is special in the world of binomial probability because it means that success and failure are equally likely. And it's really the only possible value of p where that could happen. But um, regardless, let's talk about what the various xi are. What are the candidates for the values that I could take on? Well, you could uh, you could get 0 heads, right? You could get all tails. You could get 1 heads. You could get 2 heads. You could get 3 heads, and you could get 4 heads, right? Those are the things that can happen. And so, why don't we just brute force write out all the different possible 4 coin head flips? So, uh, the first coin head flip I'm going to discuss is tails, 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 tails. That's a coin head flip, right? And we can see, right, that that coin head or that pattern of coin flips is the one that corresponds to xi being 0, right? There are no heads in this particular flip. All right, good. So let's go ahead to the next family of coin flips, and you might be able to guess what they are. Heads, tails, 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 heads, tails, 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 heads, tails, 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 heads. All right, and these correspond to the all of the coin flips where you could get 1 heads, right? And if we look at those really are the only way you could get 1 heads. Either the first, second, third, or fourth coin is is a is a heads. Everything else is tails, right? All right, great. So then we move on to family number 3. Family number 3 then is should be 2 heads, right? So if we take a look at what type of coins flips go there, heads, heads, tails, tails, is that sound that's pretty visible. Heads, tails, heads, tails, heads, tails, tails, heads, tails, heads, heads, tails, tails, heads, tails, heads, and then tails, tails, heads, heads. And we count 1, 2, 3, 4, 5, 6 of them. So those correspond to the 6 different ways you can flip a coin and get 2 heads. Right? Then in the next column we have 3 heads. So let's write them out as heads, 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 tails, heads, heads, tails, heads, heads, tails, heads, heads, tails, heads, heads, heads. Right? Those are all the same as well. And finally, in the very last family, we're going to have 4 heads, and there is exactly one of those. Right? Now, do we see then that these are all of the possibilities of coin flips? Right, what we have are all of the only tails, one like no heads, one head, two heads, three heads, four heads, right? And if I add them up, there's 1 plus 4, which is 5, plus 6, 11, plus 4, which is 15, plus 1, which is 16. 16 different coin flips, right? 16 different coin flips, and it makes sense that there's 16 possible sequences because there are 4 coins and there's 2 outcomes per coin. So if you flip one coin, you get heads or tails, and so that's 2 outcomes. If you flip 2 coins, those could all end in heads or tails, so that's 4 outcomes. Sorry, I can't. 4 outcomes. If I flip it another coin, each one of those sequences can end in heads or tails, so that's 8 outcomes. And then flip it one more time, then that's 16 outcomes, right? And so there are 16 different outcomes. And note that, again, this is special because P is 0.5, that all of these outcomes are equally likely, right? So this guy has 1/16th chance of happening. That guy has 1/16th. That guy has 1/16th, right? 1/16th. Also, all these have 1/16th. This final result has 1/16th, and all of them have 1/16th as well. Every single thing has 1/16th chance of happening. So you might ask, hey, if they're all equally likely, if all the outcomes are equally likely, because heads and tails have the same probability, then shouldn't the probability of getting 1 heads be the same as getting 0 heads or 2 heads? The answer is no, of course not, right? Of course not, because even though each one of these 4 outcomes are equally likely, there's 4 outcomes here and only 1 outcome there, right? There's 6 outcomes here, there's 4 outcomes here, there's 1 outcome here. And so if I were to write out the respective probabilities, this is 1 times 1/16, right? This then is 1, 2, 3, 4. 4 times 1/16. This column here is 1, 2, 3, 4, 5, 6, 6 times 1/16. These 4 here are another 4 times 1/16. And then finally we have one more 1/16 for a lonely final guy, right? And so none of those outcomes, well, not none of them, but 2 heads is the most likely outcome, and that makes perfect sense, right? Because if I flip 4 coins, 2 heads should be the most likely outcome. It's half the heads, right? Then 1 head and 3 heads are equally likely because 1 head means 3 tails, 3 tails means 1's heads, and heads and tails are equally likely. And similarly, no heads, no tails should also be equally likely, right? And so if I were to then sit down and write a probability distribution table, for xi, well, my xi values could be 0, 1, or I need a little bit more space than that, 2, 3, 4, and the probability that x is xi, well, that's going to be 1 out of 16, 4 out of 16, 6 out of 16, 4 out of 16, 1 out of 16, right? But there's another connection. This 1, isn't that 4 choose 0? Where did the 4 choose 0 come from? There's 4 coin flips, none of them are heads, so I pick none to be heads. That's 4, choose 1. Where did that 4 come from? There's 4 coins, I pick 1 to be heads. 4, choose 2 is 6, I choose 2 to be heads. 4, choose 3 is 4, I choose 3 to be heads. 4, choose 4 is also 1, I choose 4 to be heads. And this is underlying this particular fact that we've been using this whole time, that the probability that x is k in general for a binomial probability is n choose k, p to the k, 1 minus p to the k. And in our case, n is 4, p to the k, 1 half is p, 1 minus p is also a half. And so this all simplifies to 4 choose k times 1 half to the 4, which is 1/16, which is exactly the 5 numbers that we got up here. So we could go back to this initial setup here, cross out fair, cross out the 0.5, and replace with whatever we want p to be, and then all of these probabilities here will shift somewhat. But the bottom line is that there are more ways to satisfy the condition for some values of xi than for others. And that's going to affect the probability. And we probably should have noticed this if we were paying attention to the binomial probabilities, right? So if we've been using the binomial probability calculator, let's do the one we just did. We clearly see that not all of these are the same height, right? It's plainly obvious that they would not all be equally likely. And I guarantee almost every time you entered in any pair of values for n and p, you saw that they weren't equally likely. And there's no reason they should be equally likely because they don't describe the same events. So why would they be equally likely? The only time, and I'm pretty sure about this, that you can have 2 equally likely is if you flip 1 coin, that's heads or tails. And then, yeah, they're equally likely. Look at that. But other than that, I don't believe it's actually even possible. So hopefully that clears up some issues about the binomial probability. Please continue to send me questions and that you have about the homework or the concepts in this class. All right, talk to you guys later.